All right, so for assignment 4, and I'll put a new video up here that will specifically say that's for this year, so you guys can just watch assignment 4 part. As this assignment is, I want you to download a text file. You're going to save that as the file name called story.txt. All right. Then you're going to create a script that does these simple points going all the way down. So we're going to go ahead and get that started. The first thing to do is open up this text file in a new window. And you should get a Sherlock Holmes, The Adventure of the Engineer's Thumb here, right? So to download this, the easiest way is to open it up in a new tab like you see here. You right-click on this and go to Save As. And in the Save As, you want to save it in a folder called story.txt, all right? Not this new story. That one can go away. Let's delete that. Should be called story.txt. So we call it story.txt and hit Save. Wherever you want to.
Or no, if you go.
Right-click on this and go to Save As. Oh. Yep. It's going to call it engr.txt, rename that to story.txt. Okay. Now, in that same folder, wherever you saved it, we want to have our script file. So we'll start up idle. And we'll file new file. And we need our initial comments, as we can see here, for our points. So let's go ahead and just copy these out so we know exactly what they are. To here. Just do a block comment over these so we don't have to do each line. There we go. All right, so we need our initial comments. Those are pretty simple. INF360 programming with Python. Whatever your name is. And homework 4. Okay. Now we're going to read the file story.txt and we're going to store the lines. The key there is the word lines as the variable called story. And you must use relative paths, assuming that the story.txt file is in the same folder as your script. All right. So, does anybody remember how we open a file? Story file equals open. Okay, so story.txt. And then do we need anything else after that? Okay. All right, that will open the file and store that as a variable called story file. Now, how do we read in the lines or store the lines? Story equals story file dot what? Read lines, right? You can use read, but it won't read in it as lines. It'll read it in as text, right? We want to read it in as lines. So what does lines do? That should give us story, which is now a what? It's a list, right? And it's each line that was in that text file. So if we go look at our text file real quick. Okay, so each one of these lines, the first couple ones are empty, right? And then we get down to like this line here, and then this line. All these lines are going to be stored. Each one of these lines is a new chunk of text in the file, right? And you can print that out to make sure that you get the result you're looking for. Now, when you do this inside idle, it's going to smash it down because there's a lot of lines of text, right? So for this one, again, you want to make sure you store it in the same folder as that story.txt because we're using relative paths. So you don't need to use the path module and all that kind of stuff for this assignment because we're just dealing with relative paths. Does anybody remember the difference between relative and absolute paths?
Like starting from
It could be.
Don't you have to specify that that's that?
Yeah, so like this list here, this is an absolute path. In this case, it starts not necessarily with the home directory, but the root drive, right? So obviously being Windows instead of Linux. I knew where you were coming from. So with this side of it, it starts with a drive, and then you have the subfolder, another folder, the next folder, all the way down till you get to the actual name of the file, right? In a relative path, you just give it the name of the file, and it assumes it's in the same folder as what you're currently in, all right? So when I run this, you can see that we don't get any output. We just get squeezed line or squeezed text, 674 lines. And if we look at that, and yes, we want to expand it, you can see we get a bunch of new lines until we get to the section where we actually have that text. Now, by me clicking on that and bringing this up, this can crash your laptop, desktop, whatever, if you don't have enough RAM. Okay. So if you're getting sluggish or it's not quite working right, as you can see in mine right now, it's because it loaded up way too much for what idle can handle. That's the reason it squeezes it by default. Okay. So now that it's not responding, we should be able to just end this. Lose the program. And we'll reopen that one back up. Okay, but the key is that we now have a list of all the different lines as it goes through. All right. So the next one is write a regular expression that will find all the occurrences of the phrase Sherlock Holmes. So we need to set up a couple variables here. What does our regex look like for Sherlock Holmes? Does anybody remember how the regex works? Sherlock. Okay. 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 So we take a look at this. Remember that we have to import RE, right, for this regex to work. So up here at the top, we import RE. That will get us the regex module, and then we need to compile whatever phrase is in here. Does anybody remember what the little R means? It's not cooked, it's raw, right? So this means it's a raw string. And the idea there is whatever's in this string is what it's going to search through. Now, there's a bunch of things that we can add in there, /Ds. You guys should remember those from the videos. Check for what? So say /d. What does that look for? Digits, right? In between what? 0 and 9. So if you guys remember in the videos, it took you out here to regex101.com. And this is a great way to test your regex strings and things that you may need to look through. So you look at Python over here on the left. We can see our regular expression up here. We can do Sherlock Holmes up here. And we have to insert a test string here, right? Well, we can just come in here, grab this entire story and dump it in here. And now we should be able to figure out where all the matches for Sherlock Holmes are. All right. This is a great way to test your work and make sure what you're getting in your script actually matches what you expect. So by default, we see we have how many matches up here at the top? 5, right? So we should expect, if our code works correctly, we would see 5 examples of that. All right. If we look over here in the lower right, you have all these examples. Let's see here. Sherlock. Yes. Yep. Good work, Jared. I'm gonna put you at the top there so I can see you. You guys can see all these different examples where you have word boundaries with lowercase b's. You have non-word characters, 0, etc. A bunch of different options down there, right? This helps you build your regex string across the top. All right. So if we go back to our assignment, there we go. We have ours for Sherlock Holmes. This will allow us to do that. Now we need to use the substitute method to replace all the occurrences of Sherlock Holmes with your name. Now, before we do that, we need to find all the occurrences. So how could we write a occurrence that would keep that? If we look up here, we say using the substitute method, replace all the occurrences of Sherlock Holmes with your name and store the count of those occurrences as a variable called found count. All right. So that means we need a variable called found count to start. Found count. And that should start at what? 0. Okay. And so how would we go through and look through our story list in order to figure out whether or not Sherlock Holmes exists in that line? Okay. So what would that look like? Or line in story. Okay. It's all right. So how do we actually look through that line to see if it matches our Sherlock Holmes? Could use dot search. What's the difference? You have find all. What's the difference between search and find all?
Won't find all, find like the words. Like, if the word is in another word, won't find all.
Search will do the same thing. What's the big difference between search and find all? It's right there in the name of it.
Search only do one.
There you go. Search is going to find what? The first occurrence, right? It's like when you go to Control F in your browser and you type in something for its search, or you go into a Microsoft Word document, you do a Control F. You are doing a regex search when you do that. It's matching specifically on what you typed. Search is going to find the first occurrence. Doesn't matter how many there are, it's only finding the first occurrence. So the problem here is if we use search, it's only going to find the first occurrence of whatever we search for. It doesn't actually look to see if there's more of that in that particular line. So search works in this case, turns out, because Sherlock Holmes is never in more than one line at a time. Right? But we're going to use the right one, which is find all. Now, what does find all do? Finds all the occurrences, obviously, but what's it return back to you? Returns back a list of everything it finds, right? So there's some benefit to that. So let's do a search for this Sherlock, right? So we could do search equals Sherlock, right? Because that's what we called our regex up here. Dot find all. And we want to search through what? The line. Right? We don't want to search through story because that's a list, right? We're going through each line and searching to find all those occurrences. Now that's going to return whatever results it found to search, right? Now, what's the benefit of doing that as a list? We need to increase our found count, right? If we found a result, we should increase found count. So what would our line look like for increasing found count? This should be a capital C, by the way. Go. So does anybody remember how we increase the count? There you go. So found count plus equals what? What's that? 1. All right. So if we found it, go ahead and add 1 to the story. Okay. And then if we want to actually replace that line, what would that look like? You could. Yep. So replace Sherlock with actual name. Pull this up here. There we go. And let's see, another check came in, a list. Yep. Okay, so replace Sherlock with an actual name. What does that look like? We need to go back through our list again, right? Of story. So for line in story. Then how would we go about using the sub? Well, we want to use our regex. So what's our regex variable name? Sherlock dot sub. And when we use sub, we need to pass what? Right. The first thing is whatever we want to replace it with. So we would do something like Jason Zeller. And is there anything else I need to pass it? Line. I actually need to pass it the string that we want to search through and replace. Now, if I do this, this would work, but it would be better if I go ahead and set a variable with my name in it, because we're going to end up needing that later on, right? So if we come up here at the top or wherever, it doesn't matter. Instead of regex setup, we could call this variables. And here's where we could do our found count equals 0. And we also need to set our name equals whatever you want it to be, right? And then instead of putting our name here, we could just put name, right? Because that's going to plug in whatever we used for name. But anywhere else in our script that we want to use that name, we don't have to retype in Jason Zeller every time. We want to use a variable. That way, if it changes, we can change it, right? All right, so this is going to find all the occurrences here. Then this next step is going to replace Sherlock with whatever name that you had up in this variable. All right. It's going to replace it in that line, and it's going to be modifying story overall, right? Because we went through each line in story. So that works. Now, what do we need to do next? We need to write a regular expression that will find all the occurrences of the phrase the. All right, so very similar to we did with this regex up here, we need to write one for the. What would that look like? Doesn't matter, whatever we want to name it. The reg. Compile. Okay. And then the. All right. So let's do a test here. And let's go do our search out to regex. And we're going to take out Sherlock Holmes and we put in the word the. Now, how many matches does it say we have up here? 538, right? Jared's got the right answer here to some degree, but we have 538. Does anybody see anything in this test that could be a problem? Exactly. It's finding it in things like Hatherley's, these, does, other, therefore, etc., right? So we need to use some settings in order to make sure that we just find the letters THE. All right. So out of all these references over here, which ones would help us find THE? /B. All right. So /B. And do we need another one on the other side? Okay. Now how many matches do we have? 407, right? So usually most people don't find /B. You guys found it because I said it in the video. Hey, pay attention, hint, hint, wink, wink, right? What is another one that you may use right off the bat in order to find out whether or not it's the right one? There's another one up here. My mouse may or may not be on it. /W, right? So if we use /W instead, which said a word boundary, well, that makes sense, right? So if we said a word character, that found 47. So that one's not quite right. Okay. /B is another way of doing it. You may be finding something like, what else? What else is going to be coming before the and after the? Spacing, right? So another way of doing that is maybe looking for a white space character before and after. So if we do a /S and a /S, now how many did we find? 406. Well, that's not the same as 407. But it's almost right, right? I mean, we're within one match of not being right. Does anybody know what must have happened during this one instance? that would make this regex incorrect?
Is there a comma? Is there a period?
In theory, we shouldn't have a comma, right? Grammar says we shouldn't. And we shouldn't have a period because in theory it shouldn't end in a period. So why would we not have a space before it or after it? Oh, like a capital the? Yeah, so you'll notice like here, we didn't find the, right? But that's okay. And I'm okay with whether you find capital or lowercase. And that's one that Jared found here is something like a capital THE or all caps THE. That would help with this regex ignore case that he listed here. And that's true. We could search for lowercase, uppercase. If you wanted to match something like that over here, you could use the RE ignore case. Another way of doing it would be like putting this in parentheses, right? What's the parenthesis do? Does anybody remember that? Parentheses and regex. Does anybody remember what that does? It sets up a group. It means we're specifically looking for this group of whatever's inside of there. So you'll notice you still end up with 406 in the group, so that doesn't quite help. What ultimately happens is at some point, right there on that line, what do we have? We have it on a couple lines, so it's not that one in specific, but what happens is we don't have any kind of white space character after the. It could be where the line wraps around, something like this. And that's because we broke our story up by lines, right? We didn't actually pay attention to text. We paid attention to lines. And therefore, there could be a spot where the sentence starts with the THE because of the way it wrapped around to the next line. At some point in here, that's ultimately what happens, the difference between the two. So the correct answer is going to be /B. All right. That gets us our 407. You can also test this if you open it up in like Word and do a Control F and find, but you have to make sure you turn on match case only, right? That gets you your 407. Now, if we wanted to find all the capitals like this one here, we would again have to tell it to ignore those. Notice this is case sensitive. And we could ignore case with that regex string that Jared mentioned here. So it would look something like this one. Just going to copy that in, show you what he came up with. And he's got reg the, and then we got our /B's, and then we can use ignore case in order to make sure we don't care what characters. Now that's going to change the count, and I accept either one of those answers. It's either 407 or another one. But if you get 538, then I know that you are finding other ones like the, other, brother, therefore, etc. All right. So we're going to run this and we'll get a different count, and we're going to find a couple that have things like capital TH or something like that. You could do either one. Technically, the way this pulls up here is I just have lowercase the in the quotes, and I don't specifically mention anything about case sensitivity. So realistically, this would be a correct answer because it's specifically looking for the lowercase the. But if you went through the trouble of figuring out how to ignore case, I'm not going to complain about it. All right. So now that we are looking for that, our goal is to create a variable called the count and store the total number of occurrences of the phrase the. All right. So how would we do that? Yep. We start off with a 0, 1. So the count equals 0. And then how would we go about adding to that? Yep. So for line in story, what do we need to do? The search. Okay. In this case, he called it reg the. And then what do we use here?
Find all.
Yep. So find all. And we're searching through what? The line. Then what do we have on the next line? Not a trick question. We can just look further up there.
Wouldn't it be the count?
The count plus equals 1. Okay. That gets it started here. Let's see. Then we want to print to the user the original name, the replacement name, and the total number of occurrences using the print command with a formatted string literal, right? So if you guys remember how to use those literal strings, back over here. How would we use a literal string to print here? Print. What are we printing? Huh?
The original name for Sherlock.
Exactly. The original name was Sherlock Holmes. New name is. Right. So instead of using plus e and then adding all that in, that's the beauty of a formatted string. We use a brace, and then we just type in the name of that variable that we used for the name. That's the reason I stored Jason Zeller as a name up here, was so that I could reuse it down here as name. Okay. And then the last part is it wanted you to tell you the total number of occurrences. So how would we do that? The total, the total number of occurrences is found count, right? Found count. Again, we use the curly brace to put in our variable names. So using F strings is a whole lot easier than using plus equals blah. Now, what's the other beauty of using curly brace here as opposed to, say, string concatenation? It's less code, but the goal here is that you can format the string exactly the way we want it, with the decimals, etc. The other part is found count is a what? What type of variable is found count? You don't have to change integers to strings. Yep, Reagan nailed it. So because found count is an integer, we would normally have to convert that to a string, then plug it into our thing for us to print it, right? With a formatted string with an F, we do not have to do that. It automatically does that for us. So it's a whole lot easier to use F strings, AKA use those in your midterm projects, right? If you're printing out variable names and things, it's a whole lot easier to use an F string than it is to do a whole bunch of string concatenation. Okay. So we have that one. We need a second print statement that says what the total is for the count. So the total number of occurrences using the. So the total number of occurrences for the is, and then we could put something like what? The count. Get us in there. Oops. There we go. And then the last step here is save the story out to a new file called newstory.txt. So does anybody know how to do that? This is, for whatever reason, tricky for some people, but it's really not. New file. Open. Okay. You could use path, but we don't need to use path here. You're on the right track, though. The idea is that we just plug in our what? Whatever the name of the new file we want, right? So new story.txt, make sure it's in the matching what was asked in the homework. And then is there anything else we need to do here? Yep, we closed it. Is there anything else we need to do with that? We need to open it in write mode, right? So by default, it has this R here, and that R means that we open it in read mode only, right? If we want to write to it, we need to use W. And W allows us to write to that file now. So we opened it. Now, how do we write those lines out? New file dot write. And then what are we writing? He's got it up here. New story write mode. Yep. What do we need to write out? Not story file, but story, right? That's where we edited and changed all of our lines, was in our variable called story. So we need to write out story here. And then what do we use after that? Whenever we open a file, we also have to close the file, right? So new file dot close, and we just use close there. Okay. Now we also need to make sure we close this file up above, which we didn't do. So story file dot close. All right, let's see what your code does here. So we're going to run this file. So we got an error and we got some other numbers up here above. We have the total number of occurrences is 959 for Sherlock Holmes and Jason Zeller. That doesn't sound right. What's the number supposed to be?
407.
So this one should be 5, right? We're a little off there. And the total number of occurrences for the is 959. Something's not adding up, right? We also have an issue on this line that says the right argument must be a string, not a list, right? So let's tackle that last one first. Here we plugged in story. This is expecting a string, not a list. Story's a list, right? So how could we write this out? Both of what you guys said, right? So you could do this as an option. So for line in story, new file dot write line. And then let's go ahead and try to run that and see what happens. Okay, looks like it worked. Let's go look at our file. And here's our news story. And it looks like it did it, but what's the problem here? We didn't actually write anything that was in there, right? But it did go ahead and store the file. So that's one thing. So yes, this works. This is one way of doing it. There's also an option called write lines, which because we used read lines, we would probably use write lines, right? And write lines allows us to write that so we don't have to go in a for loop. Okay. Yep. You just use write lines as opposed to write. If you do write, you have to put it through a for loop so that you get a string out of it every time you write it. Okay. So let's go up and look at Sherlock Holmes. Notice that in that output that we got from this, that these two numbers matched, right? It means whatever we're doing it wrong, right? And what is 959? Where are they getting that number? That's the total number of lines in story, right? We could check that if we come up here to our story and we just real quick did a print story. And we would need to check what for story? The len of story, right? That should get us some kind of number. And what do you know? We get 959. So we know that this is adding 1 for every time we go through that line. Well, if we're going through it every time, that's probably an issue in our for loop. So if we look at our for loop, we're doing a search for Sherlock and we have find all, and then we're doing what? We're just adding 1. So it doesn't matter whether it found it or not. It just always adds 1 every time we go through the line in the story. So what should we really be adding to found count? What's that? You could do if, but find all returns us a what? You guys said it earlier. Find all gives us back every occurrence of what we're looking for, right? Which returns it in a list, right? So why don't we just figure out how many results were in the find all and add that to found count? Makes sense, right? So how would we do that? How would we find the total number of results? We could use len again, right? So len search will give us the total number that it found, and then we're going to add that number to found count. So whether it found 1 result or 500 results, that's what we're going to add to our count. Okay. We probably need to do the same thing on the and use len the search so that we can add all of those occurrences back. Let's go ahead and hit run here. See what we got. Now we have some numbers that look right. We have 5 and we have our 407. Everybody see what happened here and why we needed to use that? If we just use 1, then every time we go through a line, whether it found something or not, doesn't really care. We want to total the number of found. And if it didn't find anything, we're just going to plus that equals 0 if the len is 0. All right. There's a couple other ways people have done this in the past, particularly on the, where we just add 1 if it did. So say we used an if statement, right? Like what Gage was talking about. If we did an if and it returned a result, but we just added 1, well, that would work for Sherlock because it turns out Sherlock is only in each line 1 time. But when it comes to the word the count's way wrong because it's 300 and something because there's multiple thes in some of those lines. So by using len, we can calculate however many there was in each line. Yeah. Okay. So our last issue that we just ran that, we go to news story. Well, now our news story file is empty. That's a problem. So let's go to our code. Why are we getting an empty file? Anybody see the mistake down there? It shouldn't be line. It should be what? Story. All right. Let's go ahead and run that. Now we got our numbers and everything's correct, but let's go look at our file, make sure we got the right file. News story. And we have our story. But what's the problem with story here? Never changed it, right? So how do we go about actually changing that? We know it's finding it correctly, but there's an issue here with this sub. So if we look at this sub, what's actually going on here? We have our Sherlock.sub. We're looking for whatever it found, right? When it found Sherlock Holmes, we're going to replace that with our name inside of this line. What's the problem with the variable line inside of a for loop? How long is it valid? Just for that loop, right? So the variable line is only good for the occurrence that it goes through that loop. So yes, it goes ahead and replaces it, but then we start over with the next line and it doesn't really matter. So what should we be doing? Yeah, we should probably write it to something, right? So say we start with a new file, new story equals an empty list, right? And then when we do this substitute, if we set that to some kind of variable, right? So something, doesn't matter, is that. And then whatever that line is, if we replaced it, we need to add that something to our new story list. So how do we do that? How do we take a variable and add it to a list? Does anybody remember? Append, right? So we would have something like new story dot append. And what do we append here? Not name, but something, right? We can use whatever variable name we want here, but that's what we need to plug into our append. All right, so what that does is it's going to do a search through this line. If it finds the word Sherlock Holmes, it's going to replace it with our name, and this something is equal to whatever that line was. Only now it's been updated. We substituted out. If there was no Sherlock Holmes in it, then it's just the line as it was. And we need to append that up to news story. Is there any other change we need to make to our script here before we try it? Well, let's just run it, see what happens. Okay, our number of occurrence is still good. Let's go out here and look at our new story. Didn't work, right? Well, at least the output of that didn't work. We created this variable called new story, but what do we got to do with that? We assigned it up here.
I'm getting done.
Probably got a typo somewhere. Somebody down here. There we go. We need to update our write lines to the new story, right? So just because we are still writing out the original story, we need to write out the new story list so that all those go out to the new file. So now if we run this, great catch, Caitlin. And we run that. There we go. Now our numbers are correct, and we go out and check our new file. And sure enough, it has replaced Sherlock Holmes with whatever name we told it to. All right. So at that point, you guys now have the file as it goes all the way through. So I'll hold this on the screen here for a little bit so you guys can see it. Regex is pretty tricky. As I mentioned in the video and such, out of all the programming and things I've done in every language, regex is always a pain. But it can be super, super powerful when you guys are trying to figure out something very, very specific. Yeah.
I'm getting an error that says
Line 13 not readable. So if you come up here to options and go to show line numbers and then go to line 13, what do you got?
story dot right line.
No, we shouldn't have new story on line 13. That should be at the very bottom of your file. A couple of the other ones were getting wrong numbers. You still getting those?
But like it literally was just printing out the account name, and it won't actually print out like the numbers.
Okay, so it's printing out curly braces the count.
Yeah.
So what do you think you might be missing? You come down here to your print statement. You sure you got the F in the front?
Oh,
Can there not be a space?
sure.
Nope, can't be a space after it. Just needs to be straight F and then the bracket. It's like the R means raw string, the F means a formatted string.
It's still there.
And you're using curly braces and not square braces?
Okay.
Yep, make sure you're using curly braces. That's all
I
right.
think so.
Let's see. We are assuming it's on Windows and I don't need to import path from pathlib, or does it matter on relative paths? It wouldn't matter whether it's Windows or Linux, right? So because the whole point of this is that we're using relative paths, then you just need to put in this part here. If we were using absolute paths, now we have an issue, right? Because absolute paths is going to be a problem for your absolute path to your file will never work on my computer. If I put C:users JSON / OneDrive, blah, 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 and then we run it on your computer, what's going to happen? He doesn't have a JSON user on his computer. I mean, he does. Yeah, right. You're welcome. But it wouldn't find the file. That's the reason we use relative paths, not absolute paths for things. The only time we want absolute paths is if we absolutely know it's going to be in that folder structure. For example, we installed software, right? We installed idle. We know idle is getting installed to program files / Python / etc. Right? We also didn't need to know whether it's Linux or Windows, because in Windows, what is the root drive? In Windows, what is the root drive? C, right? In Linux, it is what? Right, just a slash. And it goes the yep. So it's different between the two. That's when you want to use path. So if you guys are trying to write software that needs to be universal between Mac OS X and Windows and Linux, then you can use the path module for it to pull relative paths. Or I'm sorry, absolute paths. But if it's relative paths, doesn't matter what operating system we're pulling it off of. It's just making sure that that file is in the same folder as the actual script. Yeah, Orrin?
Says the found count plus people find search count.
Okay, so found count plus equals lin search. Does your search look like this? Sherlock.find all in line inside of line for line and story. Then make sure your Sherlock actually matches your regex line up here. All right, anybody else getting errors, issues?
I didn't do the. I didn't do the lens search.
Gotcha.
Oh,
All right, so that should get you through homework 4. Again, I apologize for being out last week, and regex is not easy. So yes, there was a recorded video, but regex is not an easy topic. So use this one, watch the video, make sure you got the right homework 4, and then submit that up. All right, I'll stop the recording.